Hi everyone, welcome to my channel. Thanks for tuning in. I'm here with you to solve another question that might come up in your interviews, and this would be a great opportunity to just learn about programming and computer science in general, specifically data structures and algorithms. So the classic, relatively easy question that I have picked up for today is a two-sum question. You probably have seen this in a lot of places. In Leetcode, this is question number 1. So let's take a look at the question prompt, and let's go over that together. Given an array of integers num and integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Here's an example. If you have this input, 2, 7, 11, and 15, and the target that we're looking for is 9, we'll only have one answer, and that is the indexes of 0 and 1. So it would be 2 and 7, because 2 plus 7 is equal to 9, so we're going to return a new array including 0 and 1. We have example 2 here, 3, 2, 4, and the target here is 6, and the outputs that are provided here are 1 and 2, simply because if you add up 2 and 4, the result will be 6, so we're returning these indices. It's the same case for 3 and 3, this example number 3, because 3 plus 3 is equal to 6. Now we have a certain amount of constraints. One of the important things to know is that only one valid answer exists. And we have a follow-up, which we're going to get to that in just a little bit. So right from the top of my head, if you reach a question like this, and you have elements like 2, 7, 11, 15, one way that you can approach this question is to pick any of these elements in the array, and then go through the rest of the array trying to find elements that do the elements that would be, in other ways, equal to what is the value of target minus value 1 will be equal to value 2. So we simply, in here, target is 9, pick up value 1 to be 2. So we need to look for a 7 in the list. So we go over and search, and we'll find 7 here, and then we return the indices here. 0, 1 will be our answer. All right, let's get to coding. So we're going to be using Kotlin to solve this problem. One of the great things that I love about Kotlin is how easy and simple it makes going through different lists or arrays. So here we have nums, and I'm going to call this I1, and V will be values. And simply need to call this function on it, index, and then can access both the index and the value on each iteration. Now, we do need to find target minus V. So we simply try to do this, call I2 and V2. Let me call this V1. Nums with index. Perfect. Now, if target minus V1 is equal to V2, we're going to return a new int array of I1 and I2. Since we know that only one valid answer exists, if we have reached this point, we could just simply return an empty array, but I like to throw an exception. So I'm just gonna throw an illegal state exception on valid answer not found. Was not found. All right, let's see how this works for the inputs that we have provided here. Illegal state exception, that looks good. Expecting member declaration. Got a return here. Yeah, that should be okay. Well, maybe it's expecting us to return an array, so let me just do this instead. Oh, I'm so sorry. This should be within this function. All right, this should solve our problem. So we got a correct answer for 3, 2, and 4. For case 2, okay. Oh, we have not checked to make sure that I1 and I2 are not equal. So that's also important. I1 should not be equal to I2. Perfect. Let's submit this solution. Awesome. So we got a accepted solution. Time-wise, this algorithm would be of O n a square, which is not really ideal. The space complexity is O of 1 constant because we're not using any extra memory. So we can indeed improve this algorithm. And one way to do that is to simply, as we go through this element, use a different color here. So as we are going through these elements, we create a mapping between their indices and their values. So we do map 2 to 0, 7 to 1, and 11 to 2, and so on and so forth. So you got the idea. So the next time that we reach an element, let's say we are here and we have found 2, we add it to the mapping, and then we look in the mapping to see if we have a 7. At this stage, we only have these 2. So we don't return any answer. Then we reach this stage, we add these 7 to the mapping, and its complement would be val2, would be 9 minus 7, which would be 2. So we do found that we have an answer, and then we're going to return 0 and 1, these 2 as a pair. Let me show you how that works in code. So we're going to introduce a map, and this would be a mutable map in Kotlin, and it would be a mutable map of integers to integers. Now, we do not need to do this inner loop anymore. We can get rid of that. And simply, we need to check. Oh, we're going to add v1 to the mapping. And then we need to check if, yeah, there's a mapping that exists with this value. So let's do that. I'm going to check if you have mapping with this value. And we know that in Java or in Kotlin, if the mapping doesn't exist, it will going to return a null. So here we can check whether that value is not null. So if that value is not null, I'm going to make use of that. So if I1 is not equal to the value that you have got here, then we have found an answer. So it would be I1 and it. And this should work. This should work perfectly. We're adding stuff to memory, so our space complexity would be O of n. But this way, we only go through the array once. So our time complexity would become O of n, which is way better than O of n squared. And these days, it's much easier to throw memory at problems rather than time, because time is something that's still very valuable. So let's run this and see if things will work as expected. Okay. One valid answer was not found. Okay. So we're going through the answers in here. We've created a mutable map of integer to integers. Then we're going through the array, and we're putting we're mapping the value to its index in the array, and then we're checking if the complement of that value already exists in memory, in our mapping. Looks good. I think there's not really an issue, but let's give it another chance. So I kind of thought about this, and I think the problem is happening because we are not doing this first. So if we have a test case like 3 and 3, this will cause an issue and it would not give us the answer. So we need to check this first, and only after that add the value to our mapping. So let's see if this runs. Okay, so we got working. But what I'm trying to say here is if we are given a different example, like 3 and 3 and 2, and our target is 6, as we are going through this mapping, if we follow this approach in which we are adding that element to the mapping first, we'll have 3 mapped to 0. And then we're going to see if that mapping exists. It exists, but its index is equal to 0, so nothing will be returned. And then we'll get here, and what happens is Java or Kotlin will replace the pre-existing value with the new index. So we have index 0, index 1, and index 2 here. And then this will run, again, this line, this statement, and it's going to see that we do have a 3, but the index is still 1, and 1 would be equal to 1. So nothing will be returned, and then we're going to reach this exception here at the very end of the algorithm, because no answers were found. But if we do it this way, what will happen is we first search if this mapping exists in the first round, and it does not exist because our mapping initially is empty. And then we add 3 with value of 0 to the mapping. Then we reach next statement, and we do search to see if 6 minus 3 exists in our mapping, and it does exist, and we do pick 3 here, 0, index 0, and our current index I1 is 1, and that's not equal to 0, and we can safely return the correct answer, which is 0 and 1 here. Keep in mind that this only would work if only one valid answer exists. So this is an important constraint. So let's submit this. Awesome. Our solution was accepted, and we bit 97% of the other submissions. Well, thank you very much for following me. This was one of the easiest and the most fundamental questions. I'll be solving more difficult and interesting 2 sums and 3 sums question soon in future. If you enjoy this content, don't forget to like and subscribe. I'll see you guys in next videos.